Now this part is really mind-blowing. The periodic table is actually arranged by electron configuration. Okay, so the periodic table can be divided into the four blocks. The four blocks are represented by S, P, D, and F. So basically by the orbitals. You need to label these blocks on your own periodic table. So what I want you to do is I want you to write the S block. The S block is going to be groups 1 and 2. So you can say S block or S orbital. Either of those is fine. Okay, and also we have a kind of an exception. This one is really weird. What element is this one? This is helium. Helium is an S as well, so I want you to write S for helium. Now, if I looked at the S orbital, how many orbitals, if I looked at the S subshell, how many orbitals does it have? The S only has one orbital. So that means you can only put 2 electrons in there, correct? Okay, now if I look on the periodic table, you'll see will have a total of 2 groups. That means that you have electrons there. So in the first group, group 1, you have 1 electron, so you have S1. In the second group, you're going to have 2 electrons in the last subshell, S2. Okay, if you're still kind of confused, don't worry, we'll talk more about this, and we'll talk more about it in class. Okay, so we took care of the S. Now let's look at the P block. Okay, the P block is going to be found over here. So that is going to be groups 3A through 8A. That's your P block. You need to write this on your own periodic table. Now if I looked at the P subshell, how many orbitals does it have? The P orbital has a total, or P subshell has a total of 3 orbitals. So I can draw 3 lines. How many electrons can go in there? Up to 6 can go in there. Now if you look, you're going to see that you have 6 groups. Okay, so you have like in 3A, the last orbital will be a P1. For the 4A, you'll have P2 all the way up to P6. Helium is the exception. Helium is in the S. So helium has no P in it whatsoever. Okay, so we took care of the P. Now let's look at the D orbital. The D subshell are going to be these transition metals. So I want you to write D block on your own periodic table. The D subshell has how many orbitals? The D has a total of 5. Those are the D ones look fairly funny. They look like clover leaves. How many electrons can go in there? Well, if you add all of them up, you can get 10 in there. Now look, you are going to have 10 columns. So over here, this will be your D1. The next column will be D2, all the way over to D10. Okay, and the last one is going to be F. The F orbitals are these lanthanides and actinides. So I want you to label F block on your own periodic table. If you looked at the F subshell, how many orbitals does it have? It would have a total of 7. And how many electrons can go in there? 14. And if you look, notice how you have 14. So the first group, you're going to have F1, F2, all the way over to F14. F14 will be your last subshell. Let's talk a little bit more about this on the next slide. Now each group has its own last subshell. This is what we were kind of talking about on the previous slide. We need to label these on your own periodic table. Okay, so we said that the first two groups right here, this is your S block, correct? The S block can hold up to 2 electrons. So this is going to be our first one, S1. This will be our second one, S2. Helium is an exception. This will be S2 as well. Okay, then we will look at the P block. The P block is over here, 3A through 8A. The P block, how many electrons can a P subshell hold? The most it can hold. It can hold up to 6 electrons. So this group right here, this will be our P1. So boron, the last subshell that boron will have is a P1. Aluminum, the last subshell will have a P1. Same thing with gallium, indium, and thallium. If I go the next group over, this will be a P2. So carbon, the last subshell will be a P2. Same thing with silicon, germanium, so forth. Then we have P3, P4, P5, and then excluding helium, we have P6. So that's kind of starting with neon here. Okay, now let's look at the D block. How many electrons can the D subshell hold ultimately? It can hold a total of 10. So the last subshell will be a D1 for scandium, yttrium, and lanthanum. Then we have D2, D3. We go all the way up to D10. Okay, and then we have the F orbital. The F orbital can hold how many electrons? 14 electrons. So we're going to go from 1 all the way up to 14. Okay, and then I kind of wrote over this, but it says each period is a shell. D and F are exceptions. we need to label these on our own periodic table. Okay, so the first period is going to be our first shell. So remember shells, we have our nucleus, n equals 1, that's our first shell. Then we have n equals 2, 3, and so forth. So here's our second shell, here's our third, 4, 5, 6, and 7. So the exceptions, though, are the D and the F. Instead of scandium being 4D, it's going to be starting with 3D. So 3D, it goes on to 4D, 4D, 5D, and 6D. Okay, and then with the F orbital, we start with the 4F, 5F. Okay, I want to try to do an example on this slide. I know I'm running out of room, but let's say I wanted to figure out the electron configuration of, let's say, sulfur. Okay, what I do is I start at the very beginning. So I start with hydrogen, and I'm going to go over. So I completely fill that shell. So my first shell is 1, and that subshell is S, so 1s2. Then starting with lithium, that's in the second shell. So I have a 2, and I keep filling all the way up to phosphorus. Remember, phosphorus has 15. So I need to completely fill the S, so it has 2s2. I go across the row to boron. Okay, still I'm in the second row, so I'm going to have a 2 there. I'm going to fill that all the way up to 2p6. So far I'm over at neon. I filled that. I go to the next row, which is the 3. And I have to fill that up. So it's going to be 3s2. Okay, now I'm going to cross over to aluminum, and I'm still in row 3. Okay, but now I'm in the P shell. Because for P, the last subshell is going to be a P3. So 3p3 will be the last one. Hopefully this makes a little sense to you. If not, we'll do more practice with it, and you can always ask me questions during class time. So how we use the periodic table when we're looking at electron configurations is we start at the top and we work our way until we get to where we want. So we start with the 1s, then we go to the 2s, fill it with the 2p, go to the next row, 3s, 3p, 4s, 3d, 4p, and you keep filling it until you get to where you need to end up to. Using your own periodic table, predict the electron configuration of the following. Now, because I don't have a periodic table on here, I'm going to try to draw it to the best of my ability. We have hydrogen over here, and then we have helium across the row. We're going to do the first two, hydrogen and helium, together. Because hydrogen and helium are in the first row, that's going to be our N. N equals 1. So for hydrogen, our first energy level will be 1. And then I had you write S1 on the very top. This means that the last subshell that hydrogen will have is S1. So it will be 1s1. Okay, now if I look at helium, helium is still in row 1. So we'll put a 1 out in front. Helium is that exception, and the last orbital that helium will have will be S2. So it would be 1s2. And I kind of changed my mind. Let's do nitrogen as well. Nitrogen is going to be found kind of right here in the middle. Okay, now nitrogen is going to be in what row? It's going to be in the second row. But we can't, well, let's see what the last orbital will be. The last orbital is going to be a 2 because it's in row 2, it's our shell. And then if I look, this is in the P block. This was P1, this was P2, nitrogen is going to be P3. So the last subshell will be a P3. But what I need is I need the stuff before it because I need the entire electron configuration. All I got was the last subshell, so I need to write the previous parts. Okay, so what I do is I go across the row. So I start with helium and I completely fill that row. I fill the row by writing 1s2 because in that row there's only 2 elements, hydrogen and helium, meaning there's 2 electrons. Okay, then I go to the next row. The next row is 2. Okay, I have to fill this part next. That's my S block. So I'm going to fill my S block, so I'm going to put 2s2. Now I go across the row and I get to nitrogen. This is where I get my last subshell. It's in the second row, second shell, and the last subshell will be P3. So hopefully this is making a little bit of sense. I want you to do the next slide on your own. Okay, here are some examples of electron configuration. I want you to try these and we'll check your work when you get to class.